So we're going to be looking at section 3.3, pray the board works. Yes. And the title of this section is longer than what I want to write. So we are going to title it Graphs of Quadratics. Yes. All of this information you've seen before. We're going to be looking at quadratics in two different forms today. You've looked at them in factored form already. You've looked at them in standard form already. Today, the first type we're going to be looking at, though, is called vertex form. Vertex form of a parabola is y equals a times x minus h squared plus k, where hk is the vertex. X equals h is the axis of symmetry. That's a vertical line that goes down through the vertex. That's why x is equal to h. It goes down through the vertex. It has a max or a min of k. Whatever k is, the k coordinate of the vertex, that's going to be your max or your min. Because if you think about it, this is our parabola. You don't have to draw the picture in your notes. And this is HK. Then K is going to be the minimum. Whatever the Y value is, that's going to be your minimum. Or if we had one that opened down, K would be the maximum. So how do we know if it's going to have a maximum or a minimum? What's going to determine whether our parabola has a maximum like this or a minimum like this one? What's going to determine that? The A is negative or positive. So if the A is negative, if it's less than 0, you're going to have a max. If it's greater than 0, you're going to have a min, which is kind of opposite of your intuition. You would think less than 0 would mean a small number, so minimum. But less than 0 means it opens down, so it has a max. Greater than 0 means it opens up, so it has a min. Any questions so far? All right, so if we're looking at a parabola, the axis of symmetry is just this line that goes down through the center. X equals h. Again, you don't have to draw the graphs if you don't want to. This is all review for y'all. Any questions? Okay, example 1. Find the vertex. I'm going to put AOS for axis of symmetry. And max or min. And we're going to do it for this function first. We're going to do it together. All right, so if we look at this one, we have y equals a times x minus h squared plus k. We can rewrite that in vertex, or it's in vertex form, so we can just identify the parts in vertex form. So our vertex is going to be what? -3, -5. Remember, our formula is opposite h. So this +3 means our vertex is -3. So we have our vertex. The axis of symmetry. What's it going to be? Graham, what's it going to be? It's going to be a number and a variable and an equal sign. Can you tell me how to put those together? McKenna.
Is it x equals?
It is. Okay, because our axis of symmetry is a vertical line, it has the equation x equals, like all vertical lines. Because it goes through the axis, it goes through the vertex, that x is going to be equal to -3. And then finally, do we have a max or a min?
Max.
We have a max because our vertex, not our, I keep saying vertex, the wrong word. Our parabola opens down. Our a is less than 1, so our parabola opens down, which gives us a max. So we have a max equal to what? -5. So you use the x-coordinate of the vertex for the axis of symmetry, use the y-coordinate of the vertex for the max or min. Any questions on this? Feeling good about it? I feel good about it. All right, then let's look at standard form of a quadratic. Standard form of a quadratic is the one we're used to looking at, ax squared plus bx plus c. In this case, you have two options. What your textbook does is it completes the square to write this in vertex form. So it goes through the whole process of completing the square in order to write this equation in vertex form. However, I'm not going to derive that for you right now. If you want to do that, we can do that later. What you'll find when you do that is that the vertex is equal to the opposite of b over 2a for your x function, or for your x coordinate, and then f of opposite of b over 2a for your y. All that means is find x using this formula and then plug that in to get y. So this is the formula that you'll use to find x, opposite of b over 2a, and then whatever you get for this, you'll plug it in for y. So seeing this, the axis of symmetry, remember, is a line that goes down through, a vertical line that goes down through the vertex. So it's still going to be x equals, and can you guess what it's going to be? The x coordinate of the vertex, opposite of b over 2a. Which means your max or min is going to be f of negative b over 2a, whatever the y coordinate of the vertex is. Any questions? Yes. All right, so the second equation that we're going to look at, example 2, is written in standard form. We have f of x equals negative x squared plus 14x minus 47. And we are to find the vertex, the axis of symmetry, the max or the min, and even more on this one, we're going to go on and find the range. We know that the domain of every parabola is what? You may know the domain of every parabola. Negative infinity to positive infinity. And the intervals on which f is increasing and decreasing. So our vertex, we use that formula. The opposite of b over 2a. Our b is 14. Our a is negative 1. So that gives me 7. But y'all, the vertex is an ordered pair. So how do I find the ordered pair? I need to find what you get when you plug 7 in. So I plug in 7. You have to be careful with this first term right here because the negative doesn't get squared. In our function, only the x is getting squared. So that's going to be a negative 49. And when you work all that out, you get 2. So the vertex is 7, 2. Any questions on how to find the vertex? I'm only going to do one. All right. If the vertex is negative 2, then what does that make the axis of symmetry? I'm sorry. If the vertex is 7, 2, what does that make the axis of symmetry? X equals 7. All right, Amisha. Does this one have a max or a min? A max. How do you know that? The negative a. So it opens down. So it has a max. And Houston, what is that max?
Negative 47.
No, that is the y-intercept. If we were on vertex form, then that last number would be the max. But it's the y-coordinate of the vertex. So what is it?
2.
2. Okay? Here's something we haven't talked about yet, the range. Okay, so I know that this one opens down and that this point up here is 7, 2. Range is your y values, and we go from smallest to largest. What's going to be the smallest y value? Negative infinity because of these arrows. What's going to be the largest y value? Am I going to use a parentheses or a bracket? A bracket because it does actually have the point. 7, 2. All right, and then
You don't go 2 to infinity.
no, we do not go 2 to infinity because the max, that's as high as it can go. That's as high as y can go. All right, intervals on which f is increasing. So if you look at this function, it's increasing from here to the vertex, and then to the right side it's decreasing. So when we're making our intervals of increasing or decreasing, which variable do we use, x or y, to make the intervals, x? Okay, so this one's going to be negative infinity to 7. And remember, with our intervals of increasing, decreasing, we use parentheses. And then decreasing will be 7 to infinity. Don't put a comma there because that would mean they go for the same thing. So this one's increasing, this one's decreasing. On a parabola, you're only going to have one interval of increasing and one interval of decreasing. And where's that turning point going to be? The x-coordinate of your vertex. Now, it just depends on what the left side does, depends on if you have a max or a min. For me, it always helps to draw a little picture to show whether I'm opening up or opening down. Just helps me wrap my head around it. You are asked to graph the quadratic on some of these. You're just going to go in, click on the graph, pick the x squared button, the one that looks like a parabola. You're going to put in the vertex. If it needs to be flipped upside down, that's going to be reflect over which axis? X-axis. If it needs to be flipped upside down, that'll be reflect over x-axis. If you have a shrink or stretch, you'll do it just like you did in chapter, I believe it was 2, where you moved the little slider back and forth to shrink or stretch it. The shrinks and stretches that we have are vertical shrinks and stretches on this one. All right, last thing, we have a word problem. So, application. A stonemason has enough stones to enclose. Hey, people on the video, I'm gonna pause y'all. All right, when a problem with a quadratic asks for a maximum or a minimum, what do we say we're going to use? K. Okay, the y coordinate of the vertex. So we need to write a quadratic first. So a stonemason has enough stones to enclose a rectangular patio with 60 feet of stone wall. So let's kind of draw that. Here's your rectangular patio. And it says that if the house forms one side, so we don't have to worry about this side, that's the house. Your book has a much prettier picture on the PowerPoint that comes with it of a house, but we're going to say this is the house. So we're not going to need any stone there. All right, if we let this side be x, then what's this side? X. And what's this side going to be? Remember, we have 60 feet. 60 minus 2x. Okay? So we had 60 feet, but we had x here and x here. So what's left is 60 minus 2x. So what's going to be the area? How do we find the area of a rectangle? Good. X times 60 minus 2x. And when you simplify that, you get that, or negative 2x squared plus 60x. There's our formula for the area, but that's not what it asked for. It said, what is the maximum area? So to find the maximum area, we find the vertex. How do you find the vertex when it's in this form? We can't automatically see our h and k. It's not in vertex form. Yep. So we're going to find the opposite of b over 2 times a. So in order to get the max, we need to find our vertex. So x, part of the vertex, is the opposite of b over 2 times a, which is 15. And then you can plug it back in to get the y, or you could plug it in here. Right? If this is 15 and this is 15, then what's this side going to be? 30. Okay? That would also work if you plugged in 15 for this x and 15 for this x. You'd still get 30. To me, it was just easier to do this. I could do that in my head. So let's answer the question, what is the maximum area the mason can enclose? If this is our vertex, 15, 30, what is the maximum area? It's 30 square feet. Hey, video people, I overlooked something. So our dimensions are 15 by 30. Those are the dimensions that list the max area. But to find the area, we have to multiply length times width. So if this is 15, this is going to be 30. 15 times 30 is 450. So our max area is 450 square feet. 450 square feet. Now, what dimensions give you that? 15 feet by 30 feet. And people watching the video, be sure that you go into H&R Block Budget Challenge and make sure you don't have any bills due today or due by the 28th. Any bills due by the 28th have to be paid today. The end.